Thank you so much for joining this lesson. Continue joining the lesson. Continue joining the lesson. Remember to subscribe and to share the link with your friends. Remember to be a subscribed member. Remember to be subscribed. Thank you so much. I can see people are still joining. You can share with a friend.
At least we know now he never really loved us.
Share and invite a friend. Thank you so much. Can read your messages. Can see you waiting. Continue joining. Continue joining. So as I had promised, we are going to handle mathematics paper 2, and I will specialize with section 1. Section 1. So allow me to post my screen now so that we may go through some questions together. And I believe by the end of the day, you people will have benefited. Remember to click the share button. Yes, so welcome so much. Welcome so much. Question number 1. Mathematics paper 2. Question number 1 is from errors and approximations. This is from 3 mathematics. Students should understand that in a scale of 1 to 16, that is section 1 mathematics, we usually expect not less than 10 questions from book 3. Therefore, in the 15 topics of book 3, they should be taken very seriously because they have a higher probability of appearing in mathematics. So let us talk about the question now we have here. The question is talking about the length and width of a rectangle were measured as 12.4 centimeters and 5.0 centimeters respectively. Find to 4 significant figures the percentage error in the area of the rectangle. The percentage error in the area of the rectangle. Remember, when we are talking about errors, there is what we call absolute error, there is what we call relative error, and there is now the percentage error. And I want us to address the 3 errors in the above question systematically. First of all, there is what we call the relative error in the recording of the dimensions. Then there is the relative error in the calculation of the area. That difference should be understood. There is relative error in the calculation. The relative error in the calculation of the areas. And there is also relative error, which is a different relative error now in the computation of the dimensions provided. Therefore, I will talk about the length, which has been recorded to 1 decimal place. So if the recording is to 1 decimal place, then the relative error in the recording is when we take 0.1 because of the 1 decimal place and we divide by 2. This gives us 0.05. Therefore, the relative error in the recording of the length of this rectangle is 0.05, and also the width, which is to 1 decimal place also, will have the same relative error of 0.05. So let us now talk about the range of the length 12.4. We either add or subtract 0.05, and this will take us to the length ranging between 12.35, that is when we subtract, all the way to 12.45 centimeters, that is when we add the relative error. Then the width 5.0 plus or minus 0.05. Therefore, this ranges between 4.95 when we subtract the relative error, all the way to when we add, we get 5.05 centimeters. So we have now the range of the dimensions, the range for the length and the range for the width. Now we can calculate what we call maximum area. Area maximum, this is the area when we multiply the biggest value or the largest value of length, 12.45, multiplied by the largest value of the width, 5.05 centimeters. And this is going to give us exactly 62.8725 square centimeters. Then there is a area minimum. This is when we use the lower limits of these dimensions. So we will be having 12.35 multiplied by 4.95, and this will give us 61.1325. Yeah, 1325. There is also another value which we usually call the actual area. So we're going to calculate now the actual area. Actual area is calculated by the dimensions as they have been recorded, 12.4 by 5.0. This will give us exactly 62 square centimeters. 62 square centimeters. Therefore, now we can, okay, square centimeters. So now we can talk about what we call absolute error. Absolute error in the calculation of area is usually given by the average of the difference between area minimum and area maximum. So area maximum minus area minimum, then we divide by 2. That will give us the absolute area in the calculation of the area. So now allow me to take 62.8725 minus 61.1325, then we divide by 2, and this will give us exactly 0.87. 0.87. So 0.87 is the absolute error. There is what we call the relative error in the calculation of area. Relative error is given by absolute error out of actual area. Out of actual area. Therefore, we're going to take 0.87 divided by 62. Then there is also, okay, we can first of all compute this, and we are going to have 0.01403. Then there is the percentage error, which is given by relative error times 100. We just express the relative error as a percentage. So 0.01403 times 100. This is going to give us 1.403%. That is the percentage error to 4 significant figures. Yeah, that is the percentage error to 4 significant figures. Now we can talk about number 2, which is a question on Surds. A question on Surds, number 2. Simplify. As you can see, number 2, let me clear some space here for number 2. Remember to continue inviting some friends. Remember to invite a few friends of yours as we continue learning. So number 2 now, which is on surds. We are told to simplify, and basically when you are told to simplify a surd, you are just being told to rationalize the denominator. If you see a surd on the numerator or on the denominator, then the surd is not simplified. So to simplify a surd simply means to ensure that there is no surd at the denominator. And in this case, we can see the denominator is not a binomial, it's only one term. And therefore, because it's only one term, we cannot multiply with the conjugate. So we are going to multiply with the denominator, both at the denominator and at the numerator. This is what I mean. We need to take the root of 24 plus 3, the root of 2. Then we multiply by root 2, divide by, we have root 2 here, which also has to be multiplied by root 2. So we multiply by root 2, both the numerator and the denominator. In such a case, the value of this surd is not changed, but that multiplication will help us to do away with the surds at the denominator. Now, at that point, allow me open the brackets in the numerator. That will give us the square root of 24 by 2, which is 48, plus 3. Root 2 by root 2 is a root 4. Then we divide by the root of 4. We divide by the root of 4. At that point now, we can simplify our surds. The root of 48 is the same as the root of 16 times 3. Then plus 3 multiplied by the root of 4, which is a rational number, that is a 2, divide by, this is the square root of 4 again, which is 2 at the denominator. Therefore, we have already rationalized the denominator. All right, the square root of 16 times 3 means that the root of 16 is known, and that is a value which is equivalent to 4, but the square root of 3 is not known. Plus 3 multiplied by 2, we can just go directly to the value now, which is 6, then divide by 2. And we can see that the surd is not fully simplified, because at the numerator we can simplify out 2 and remain with 2 root 3 plus 3, and in the denominator we are having a 2. Therefore, the 2 from the numerator and the denominator can simplify, and we will have a simplified surd of 2 root 3 plus 3. So this is now the final answer. That is the final answer for this surd. Remember to continue subscribing and to share this broadcast with your friends as we continue learning. We continue to number 3. I told you that in a fair mathematics paper, the section 1 comprises of form 3 questions and form 4 questions, but the form 3 carries a lot of weight, because as we continue analyzing, you see this one was a form 3 question, that is number 1. Surds is also in form 3. And now we are going to number 3, whereby we are talking about a chord AB whose length is 8 centimeters, subtends an angle APB 60 degrees at the circumference of the circle. Calculate to 4 significant figures the perpendicular distance from the center of the circle to the chord. These are chords and tangents, and again, we'll be talking about form 3 topic. So it's still form 3. So form 3s, make sure you are following, make sure you you take the form 3 syllabus very serious. Let me sketch this information. We are talking of a circle. Then there is a chord AB. Let me draw the chord or sketch. We are sketching because it's not a real diagram. The diagram is not drawn to scale. Chord AB, 8 centimeters. Then now we have the same chord subtending an angle of 90 at the circumference of the circle. So if the chord subtends an angle of 90, then we can have this diagram now behaving this way. Yes, this is a point P where we are having 60 degrees. When a chord subtends an angle at the circumference, the same chord is capable of subtending an angle which is a double that one at the center. So if we have the center of this circle here, then the same chord will be able to subtend twice the angle at the circumference. That is the angle properties of circles from 2 mathematics. So at the center, we shall have 120. If at the circumference there is 60, then at the center of the circle, we shall have twice that angle, and the value will be 120. So now we can work out the value that we want. We first of all want the perpendicular distance from the center to the chord. So from the center O to the chord perpendicular distance, if we call this one point N, then I can resketch now my diagram here such that I'm having a triangle here. If I extract the triangle, I'll have 60 degrees at this point because I have bisected the angle at the center. Again, I'm going to have 4 centimeters here because I have bisected the length AB to have point N. So now I need the angle or the length which is unknown, the height there, the height ON. So allow me use trigonometry such that I will talk of the tangent of 60 being given by the opposite length 4 out of the unknown x. So x will be given by 4 divided by the tangent of 60. And we've been told to 4 significant figures. Therefore, to 4 significant figures, that value is going to be 2.309. These are centimeters. So that is the length or the distance from the center of the circle to where the chord is. We are also told to calculate the radius. We're also told to calculate the radius of the circle. So for us to calculate the radius of the circle now, we need to concentrate with the length OB, which now can be calculated using several approaches. We can even use trigonometry once more, and we talk about the sine of 60 being equal to the opposite length to that angle of 60 will be 4 divided by the hypotenuse, which can be let to be y. Therefore, y is going to be given by 4 divided by the sine of 60. This is going to give us 4.619. 4.619 centimeters. Remember, the answer, according to the instructions, is supposed to be 4 significant figures. That is exactly what we are doing. Let us talk about a question here. A question number 4 on making the subject of a formula or changing the subject of a formula. So we are talking of make H the subject of the formula. Make H the subject of the formula. S equals to the square root of WD divided by H into H minus D out of 2. Then you close now the brackets. So allow me start by squaring both sides such that we have S squared equals to WD out of H minus D out of 2. This is where we are now. At this stage, allow me open the brackets and I will be having WD, because WD over H multiplied by H, the H cancels. But when we move ahead now, we shall have minus W D becomes squared, and we shall be having 2h at the denominator, like that. At this point now, we can have the terms with h, because it is h which is being made the subject. We can have it starting the equation on this side, squared out of 2h equals to wd minus s squared. Wd minus s squared. We can continue rearranging our terms. Can continue arranging our. Yeah, so sorry for the disconnection. Allow me post the screen again. Yeah, sorry for that. Now we can continue. Remember, we are making h the subject. We are making h the subject. Therefore, now we can multiply through by 2h, such that on the left-hand side, we will remain with wd squared equals to 2hwd minus 2h s squared. And at this point now, we can factor out our h. Then we remain with 2wd minus 2s squared. Then we have wd squared. To remain with h now, we can have our wd squared divided by 2wd minus 2s squared. So this is now the expression that gives us x. Let us continue following. We have a number 5 here, which is on rates of work. Formula and variations is also form 3. Let us not forget that analysis. We are having a number 5. Tab A takes 4 hours to fill a tank when empty. Therefore, this is again form 3. Rates of work and proportions. Form 3 work. Tab A takes 4 hours to fill a tank when empty. Tab B takes 3 hours to fill the same tank when empty. Tab C takes 6 hours to empty the same tank when full. Then we are talking about now tab A is opened. Then 1 hour later, tab B and C are opened simultaneously. Calculate the total time it takes to fill the tank. Calculate the total time it takes to fill the tank. All right. When we are talking about rates of work, we should know that if tank A can take 4 hours to fill a tank, then it means for tap A to completely, okay, in 1 hour, it fills a quarter of the tank in 1 hour. So in 1 hour, it has to fill a quarter. So that in the 4 hours now, a quarter times 4 times, we will have the tank fully filled. That is talk about tab B. Tab B is going to take 3 hours. So in an hour, it fills a third of the tank in 1 hour. So that in 3 hours, it completely fills the tank. Let us also talk about tab C, which is in this case emptying the tank. It takes 6 hours to empty. So it fills, or it empties a sixth in 1 hour. So tab C empties a sixth in 1 hour. With this analysis now, those are the rates at which individual tanks are operating. We are first of all going to have tab A according to the instructions. Tab A is opened, then 1 hour later. That means when tab A was operating alone, it filled a quarter of the tank. And now we are going to have what? The other tanks now getting opened. Therefore, the remaining after 1 hour is going to be when it is fully filled and there is a quarter now which has been worked. Therefore, 3/4 of the tank will be remaining. 3/4 of the tank will be remaining unfilled. But now we want the 3 taps now to open. Therefore, we are having in 1 hour a quarter. Then the other tank is filling a third, but we have another tank which is emptying a sixth. So A is filling a quarter, B is filling a third, and C is emptying a sixth. That is why I have a minus at that point. Therefore, when you compute that, we're going to get 5 out of 12 of the tank in 1 hour. When the 3 are working, per hour they are going to fill 5 out of 12. So we can say 5 out of 12 of the tank is filled in 1 hour. What about 3/4, the remaining fraction now? This will be 3/4 multiplied by 1 divided by 5 out of 12, which will be times 12 out of 5. And this is going to be by 4, 1 by 4, 3. So 9 out of 5 of the tank, which is 1 and 4 out of 5 of the tank. 1 and 4 out of 5 hours, that is the length or the duration taken to fill the tank. But now there is an hour when tap A operated alone. Therefore, total time will be 1 and 4 out of 5 plus the hour when tap A was operating alone. This will be 2 and 4 out of 5 hours. So that is the total duration taken to completely fill the tank. We can look at number 6. Which is talking about a certain diagram. AB is the diameter of a circle, 8 centimeters. Then BC equals to x plus, sorry, let me reconnect again. Sorry for some interaction here and there. But we are going to overcome that. Yes. So now we are talking about part 6. Calculate the length AC to 2 decimal places. Length AC to 2 decimal places. The diagram is here. The diameter 8 centimeters, length AC to x, length BC or CB, x plus 2. To 2 decimal places. So something you should know is that this is again a Form 3 topic. Okay, and to some extent a Form 2, because we should know that angles subtended by the diameter to the circumference of a circle are usually equal to 90 degrees. So the angle at this point is 90 degrees. 90 degrees. Therefore, with 90 degrees at that point, we can talk about Pythagoras theorem from 2 mathematics now. Therefore, Pythagoras theorem says that when the 2 shorter lengths are squared and added, they will be equal to the square of the longer side, which is the hypotenuse. Therefore, 8 squared is the same as 2x squared plus x plus 2, also squared. This will be 64, equivalent to 4x squared plus x squared plus, when you expand this one now, you get 4x plus 4. Then we can group like terms together and have 5x squared plus 4x. When 64 is brought to this side, it will be minus. Therefore, minus 64 plus 4 will be minus 60, equivalent to 0. Allow me solve for x following what we call the quadratic formula. It says that the value of x is usually given by negative b plus or minus the square root of b squared minus 4ac divided by 2 multiplied by the value of b. Therefore, we will have negative 4 plus or minus the square root of 4 squared is 16 minus 4 multiplied by 5 multiplied by negative 16, then divided by 2 times the value of a, which is now 10 according to this equation. Let me create some more space here. Yes. So now we'll be talking about negative 4 plus or minus 16. This will be a plus because 4 by 5 will be 20. Then by negative 60 will be negative 1200. Then when we multiply by the negative out here, it will be positive. So it will be 1216. The square root of 1216 divided by 2 multiplied by 5, which is 10. Negative 4 plus or minus. Negative 4 plus or minus. Let me multiply or carry out the square root there. And that is giving me 34.87. Divide by 10. Therefore, the first value of x is going to be, when we follow the positive, we're going to be 30.87 out of 2, or the other value of x will be negative 38.87 out of 2. So the first value when we divide by 10, sorry, this is a 10, by 10, we're going to get 3.09 or negative 3.89. This is a negative and we are dealing with length. So we stick to the first value of x, which is 3.09, which means for us to get the length of AC, then we need 2x. So 2 multiplied by 3.09, and this is going to be 6.18 centimeters. The examiner said to 2 decimal places. To 2 decimal places. So that is the length of AC. There is a number 7. Number 7 is on trigonometry. And we're going to solve the equation. This is trigonometry 2, a form 3 topic. Trigonometry 2 is form 3. So let us look at the question, then we see the possible solution to this question. Continue sharing with your friends. Continue inviting more people to the lesson. Remember to subscribe. Remember to share with friends. All right. Given that the cosine of 2x degrees equals to 0.807, find x to 1 decimal place between 0 and 360. So the first thing I would advise students to calculate is not even the value of x, it is not even the value of 2x, but the value of an acute angle that you will work with in this question. Even those who will be following the lesson later, let them know that we first of all are supposed to get the value of theta, a certain acute angle which should be gotten by the cos inverse of 0.807. And this acute angle is 36.2 to 1 decimal place. 36.2 degrees to 1 decimal place. Now it should be known that the value of 2x is going to be, we are going to draw the unit circle. Yeah, this is the unit circle. Then the possible values of 2x are going to be, because cosine is positive, then we are going to identify an angle of 36.2 in the quadrants where cosines are positive. That is the first quadrant, so 36.2. And also an acute angle of 36.2 in any other quadrant where cosines are positive. And that is going to be, in the first quadrant, we have all the angles. Second quadrant, only sines. Third quadrant, only tangents. And in the fourth quadrant, cosines are also positive. Therefore, an angle of 36.2 in the fourth quadrant is going to be 323.8. 323.8. So when we measure 36.2, then that will be in the fourth quadrant. That will be an equivalence of 30 or 323.8. Let us get other possible angles. In case we make another complete cycle, the angle of 36.2, we will add 360 to it, and it will be equivalent to 396.2. When we make another complete cycle, the angle of 323.8 is going to become 360 or 683.8. And finally, the angle of 396.2 when we make a complete cycle will become 756.2. So all these are possible angles which have the same cosine, Now we can continue and talk about the exact value of x, which will be when we divide all the values by 2 now. This will give us 18.1 degrees, the first angle. The next one will be 161.9 degrees. The next one will be 341.1 sorry, degrees. Okay, before that there is 198.1 when 396 is divided. Divide 396.2 and we get 198.1 degrees. And finally 683.8 will give us 341.9 degrees. When we divide 756.2, we get 378.1, and that will be beyond the limit. Therefore, these are the angles which are within the provided range. Let us continue. There is a number 8 here. A number 8 on expanding. So these are binomial expansions. The topic is in Form 3. Binomial expansions. Expand 3 plus 6 raised 3 plus x raised to power 6 up to the term in x power 3. Therefore, this is a binomial expansion to the power of 6, and we are going to expand it. The first thing you should know is that the powers of 3 will start at 6 and start decreasing as we progress. And the powers of x will start at 0 but begin to increase as we progress. Therefore, we will start with listing the binomial coefficients of power 6. That is 1, 6, 15, 1, 6, 15, 20, 15, 6, and finally 1. These are the binomial coefficients of power 6. So in the first term, where the coefficient is 1, we're going to have 3 power 6. Then x will be multiplied or be raised to power 0. In the next term, we shall have 3 now taking a power 5, but x taking power 1. So now you see the powers of 6 are decreasing. The powers of 3 are decreasing from 6. The powers of x are increasing from 0. In the next term, we shall have 3 power 4 and x power 2. We shall have again 3 power 3 and x also becomes 3 power 3 because x is increasing. And actually we have to go up to that value because we needed an expansion up to when we will find the powers of x becoming 3. So we are not supposed now to go beyond there. We can have those terms now. when we have a 3 power 6, let me raise it to power 6, we get 729. Then x power 0 is 1. So 729. Then plus, in the next term, 3 will be raised to power 5. This gives us 243. X power 1 becomes x, then times 6. And this gives us 1458 times x plus 3 power 4. This is 81 multiplied by 15. That is the coefficient. We're going to get 1215 and x is to power 2. Then we add 3 power 3, which is 27, multiplied by 20. That gives us 540. Then x is raised to power 3. So this is now the expansion up to x power 3. Then we are told to use the expansion above to estimate 2.97 power 6 to 4 decimal places. So we're going to equate 2.96 power 6. This is 97, sorry. 97 power 6 with 3 plus x, also power 6. If the powers are equal, then we can equate the bases. And when we equate the bases now, we can start talking about 2.97 being equal to 3 plus x. So to remain with x, we have to take 2.97 and we subtract 3. And that is going to be 0.03, negative 0.03. So the value of x is 0.03. Now we have to replace this value of x in the expansion up there. And the expansion up there will be now 729 plus 1458 into 0. Okay, it has a negative, so negative 0.03. Then we add 1215 into negative 0.03 squared plus 540 into negative 0.03 raised to power 3. Then now you're supposed to key in the expansion now, the way it is into your calculator, 729 plus 1458 into negative 0.03. Then we add 1215 into negative 0.03, now squared, plus 540 into negative 0.03, we raise to power 3. This gives us 686. 686 point. Remember, we are taught to 4 decimal places. 3389. 3389. So that is the expansion to 4 decimal places. Yeah, thank you so much for continuing following. Remember to share with friends. Remember to share this broadcast with your friends as we continue covering the lesson together. Allow me bring the next question, which is on circles. Let me create a good space for this graph. Yeah, so we are having now, the question here. The question says that the equation of a circle is x squared plus y squared plus 4x minus 2y minus 20 equals to 0. On the grid provided below, draw the circle for 4 marks. You can be sure the first 3 marks will be for determining the radius of the circle and also the center of the circle. When that is determined now, you will move ahead to draw the circle on the graph provided. Therefore, to determine the center of the circle, we are supposed to arrange such that we start with the x terms. So we have x squared, then the other x term will be plus 4x. Then we are going to add a constant at this point to make the square perfect for x. Then we start again with y squared minus 2y. We add again a constant at this point to make it a perfect square. Then the constant here is at 25, okay, at 20, plus we had a constant also, and we add another constant. So the constant that we will add to make the part of x a perfect square will be added to the right hand side. And again, the constant that we will add to make the y a perfect square, we are also going to add it to the right hand side. How do we get the constant? Constant is usually given by b out of 2 squared to get a perfect square. Therefore, we need to take, for the x, b is 4. So 4 divided by 2, then we square. We get 2 squared, which is 4. Therefore, we are supposed to add a 4 here, and we also add it to the right hand side. Again, for y, we take negative 2, we divide by 2, then we square. That will be negative 1 squared, which is positive 1. Therefore, we will add 1 here, and we also add 1 to the right hand side. Now I'm going to factorize. I'm going to factorize the left hand side. The first perfect square will be x plus, because the sign is a plus, the square of this constant, which is 2, the square root, that is squared, plus, we start again with y. The sign which follows is a minus. The square root of 1 is 1 squared. So we have factorized the left hand side, and this will give us 25. Now, when an equation is in this format, this is the standard equation, of what we call a circle. Now we will be able to extract the radius, and we also extract the center of the circle. So the center of the circle is going to be -2, +1, and the radius of the circle will be the square root of the right hand side, and that will be 5 units. Therefore, a student now will proceed to the graph standing at -2, 1, the coordinate -2, 1, which is here, and using a radius of 5 units. Now the circle will be made. So you use your protractor and make a circle using this center and 5 units, 1, 2, 3, 4, 5. So the circle will be passing at some point there. Use 5 units across. So 1, 2, 3, 4, 5. The circle will also pass there. 1, 2, 3, 4, 5. The circle will also be passing here. 2, 3, 4, 5. The circle will also be passing there. So that is now where the circle will be passing, and that is the center. So you just make the circle very keenly. I don't have a protractor, I don't have a compass, that is, but I am sure you are having a circle. Yeah, let us continue concluding the lesson now at number 10, whereby we are in kilograms are 10, 11, 12, 13, 14, and 15, while those of 6 girls are 8, 9, 10, 11, 12, and 13. A boy of the weights is recorded. Draw a space to show all the possible outcomes. A probability space is going to be drawn now for this. And now this is how we're going to come up with the probability space. Let me create a space here so that we may draw the probability space. So we're going to have masses of boys on one side, then masses of girls on the other side. So now there are 6 girls and 6 boys, so can have one. Sorry. 1, 2, 3, 4, 5, 6. So we can have the boys there. Then the girls. For the girls now, we're going to have 1, 2, 3, 4, 5, 6. So now allow me have the boys here, then the girls on this other end. We are going to have the masses of boys as 10 to 15. So we'll have 10, 11, 12, 13, 14, 15. And for the girls, we are going to start from 8, 9, 10, 11, 12, and 13. Those are the masses for the girls. So now when we pick mass of a boy, mass of a girl, and we add, we are going to have possible outcomes now, whereby for the first case, it's 10 and 8, giving us 18, 11 and 8, giving us 19, 20, 21, 22, 23. Then in the next, we'll have 9 and 10, giving us 19. The next giving us 20, 21, 22, 23, 24. In the next row, we're going to have 10 and 10, giving us 20. 10 and 11, giving us 21, 22, 23, 24, 25. Then we'll have 11 and 10, giving us 21, then 22, 23, 24, 25, 26. 10 and 12, giving us 22 is the first one. Then 23, 24, 25, 26, 27. And finally, we'll have 13 and 10, giving us 23, 24, 25, 26, 27, 28. So these are all the possible outcomes displayed on what we are calling a probability space. This is what you call a probability space. Actually, this is a simplified tree diagram, probability space. Find the probability that the sum of their weights is at most 22. The sum of their weights is at most 22. At most 22 means 22 and below. At most 22. So 22 and below. Therefore, 22 and below, we're going to count the possible sum, which are giving us 22 and below. Let me use a different color now, so that I may pick those masses or those sums. 22 and below. So this is the first one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I think those are the only options where they are at most 22. At most 22. So at most 22. Yeah, let me recount again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 possible outcomes. And out of 36 possible outcomes. Therefore, by 3, we can have 5, and by 3, 12. So this is the probability in the simplified form. So that is how we handle it. Answer number 11, use completing the square to solve. There is a 3x squared plus x minus 10 equals to 0. The first thing when using the completing the square method, probability is form 3. Equation of a circle was also form 3. Now we are talking about a form 3 topic again, the completing square method, whereby we are supposed to talk about the first thing is taking the constant to the other side. So 3x squared plus x minus 10. Now the 10 is taken to the other side and it becomes positive 10. The other thing is to divide through by 3 to make x squared have a coefficient of 1. So x squared plus a third x. We will add a constant at this point. Now we have 10 out of 3, and we shall also add the same constant this side. We make the left hand side a perfect square, and to make it a perfect square, we have to use b out of 2 squared so that you may get a constant. So b is a third, divide by 2, then we square. This will be 1 over 6 squared, giving us 1 out of 36. So we add 1 over 36 to both sides, 1 over 36. So now we factorize the left hand side, x plus 1 out of 6 squared. That is the factorized form for the left hand side. This is equal to 10 over 3 plus 1 over 36. And this becomes 3 and 13 over 36. We can take square roots of both sides now. We will have x plus 1 out of 6. This is equal to, the square root will be 1 and 5 over 6. So plus or minus 1 and 5 out of 6. This means to remain with x, we need to take either 1 and 5 over 6 minus a sixth, or negative 1 and 5 out of 6 minus a sixth. So in the first case, when we subtract a sixth, we're going to get 1 and 2 thirds. Or x equals to, when we take 1, actually we will get negative 2 exactly. Yeah, negative 2 is a whole number. So thank you so much for following. Remember to subscribe and to share the lesson with your friends.